Algebra 2, Chapter 2, Section 6, Special Functions. There's lots of different kinds of functions, and some of them only get mentioned on occasion. This section is all about being able to recognize some of the ones that are kind of unique and interesting to look at. So, the first one we're going to talk about is the piecewise defined function. The whole idea of this function is you have a lot of normal functions listed, but every single one of them is only defined over a very specific domain. All right? So the idea is you define a domain, you run the function for that domain, and that's it. And it doesn't go forever in each direction. It just fits that domain. So, we're going to graph a piecewise defined function here. Now, before I even start getting into the graphing, I'm going to highlight some stuff. If you notice, here we have the function x minus 2. So we're going to use the function x minus 2, but we're only going to use it for the x values that are less than negative 1. Then we have the function x plus 3, but we're only ever going to use that that function for the x values greater than or equal to negative 1. So basically what's happening here, and I'll start out and I'll just draw, oops, I don't want that to be pink. I actually want that to be black, all right? So here is my x-axis, and we'll just call this part right here 0. We'll draw the y-axis through that here in a second. Negative 1, negative 2, negative 3, negative 4, negative 5. 1, 2, 3, 4, 5. So, the whole idea is everything is pinning around this number negative 1. So I'm going to kind of mark that with yellow here. Any x value that's to the left of negative 1, but not including it, is going to be part of the blue function, x minus 2. Anything to the right of negative 1, including negative 1, is going to have the numbers to the right as the domain. So, what does that mean? If I'm making my table of values here, f of x, and I'm choosing my x values, what are some numbers to the left of negative 1? Well, how about negative 5, negative 4, and let's do negative 1 as well. Those three values, because they're to the left of negative 1, they're going to get plugged into the blue function. So it's going to be x minus negative 5, x is negative 5. Negative 5 minus 2, which is negative 7. And here we've got negative 4 minus 2, which equals negative 6. And even though it's not included because it doesn't have the or equal to bar, we're still going to find a negative 1 there. Negative 1 minus 2 equals negative 3. So for the blue part of the graph, I have my three values. Negative 7, negative 6, negative 3. And I know that's enough because x minus 2 is a linear, so those 3 points are definitely going to draw the line for me. And now the next idea is, so those were all part of the blue domain. And now I'm going to talk about numbers in the pink domain. So what are numbers that are bigger than negative 1? Well, let's start at negative 1, 0, and let's do 2. And we plug them into the function. And we plug them in the function this time, since they're in the pink domain, they're going to get plugged into the pink function. Negative 1 plus 3 equals positive 2. 0 plus 3 equals 3. 2 plus 3 equals 5. So now I've got my blue part and my pink part of the function all figured out. Now let's draw the coordinate plane and get my values here that I want. So we got that. Let's erase the 0. We don't need that right there because we're going to have a nice straight line go through. I need to go all the way down to negative 7. I might need some more space here. Get you out of my way. All right. Let's do a nice straight line up and down. 1, 2, 3, 4, 5. Start right there. And we'll go up this way. So now I've got my x-axis. And 1, 2, 3, 4, 5. Sorry, I've got my y-axis now. I already had my x-axis. 1, 2, 3, 4, 5. -6, -7. Perfect. So I'm going to plot the dots in the color from their domain at first so you can kind of see what's happening. But then I'm going to draw everything in a nice black line so you can see how the graph is actually supposed to look. -5 for the x went into the function x minus 2, and it goes down to -7. -4 is in the blue function, it goes to -6. -1 is in the blue function, and it goes to -3. Now here's a very important thing about this problem. There's no or equal to in this first domain, which means -1 actually isn't included, it's just everything up to it. So I'm going to use an open dot there for that specific point. And then for now the pink, I'm going to go to -1, and you can see it goes all the way up to +2. And that one, because it does have an or equal to, we're going to use a solid point. And that open point and the solid point on top, that's how we keep this as a function. Otherwise it would fail the vertical line test. Now let's plug in 0, go to +3, 2, go to +5. Alright, so now let's draw my function out nice and neat. I've got the blue part of the function, solid dot, pink part of the function. And this is why we call it piecewise. It might step all over the place and jump between spots. So this is my is how a piecewise function is defined, the kinds of things it looks like. Sometimes it might just have more functions. There might be 3 different domains, but I always like to start out thinking about my domains and splitting them apart and then figuring out which function matches with which one.